Okay, some questions related to thermocouple. As you can see, there's a solar panel and a millivoltmeter is there. You can see a millivoltmeter. The two wires which are coming out from the meter made up of same material, which are connecting different material. Uh, Figure 5.1 shows a thermocouple set up to measure temperature at a point on a solar panel. So we are measuring at this point. X is a copper wire. Suggest a material for Y. What it could be in place of X is a copper wire. Suggest a material for Y. Yeah, it should be any other because you cannot have the same wires which are coming out from the meter and connecting the two junctions. It should be different. So suggest a material for Y, material Y, that is iron. Name the component Z. What is Z? Millivoltmeter or voltmeter, acceptable. Even there's a meter called galvanometer, also acceptable. Voltmeter or millivoltmeter, both are acceptable. Practically millivoltmeter is used because two small voltages there, and this one was iron. Explain how a thermocouple is used to measure the temperature. So how we can use this to measure the temperature, the thermocouple? That was question number 5. So two junctions at a different temperature, except one hot, one cold, that you can mention. Temperature different cause the EMF, and one of the junction temperature we should need to calibrate, or we should know the temperature. So the difference between hot and cold junction, or two junctions, if you don't want to say hot and cold, you can mention two junctions. Produce voltage which can be used to determine the temperature, and one junction must be calibrated. Like we should know the temperature of the one junction, and then we can identify the temperature of the other junction. Is it clear? This is the same thing which I already discussed with you. The 3 marks, distribution of the mark, difference in the temperature, produce voltage, and one junction must be calibrated.
Sir,
Yes?
whenever we want to measure the temperature of something using a thermocouple,
Yes.
we place that object onto the cold junction.
The unknown substance.
Yeah, like the unknown substance that we want to measure the temperature of. We will always place it
Actually, no,
junction.
actually, look, first thing, we call them as junctions. Like there are two junctions, first thing, okay? But when we compare them, like for example, at one junction, I place a melting ice, okay? and the other junction I place at on a solar panel. X is already the use, so I'm not using. So example at position A. So when you compare them, as you can see, ice is having a lower temperature. So in reference to that, ice is now a cold junction and this will be hot junction. So the junction appear like hot and cold junction is a term actually used for their comparison. The idea is that one of the junction temperature should be known. Before, like example, say I was not having this solar panel and I was not having a melting ice. So I was not having a solar panel, I'm not having a melting ice. So I cannot say which one is hot and which one is cold because there is no comparison now. So in that case, I will say only junction. The term hot and cold junction is when we place the two objects, the one which is lower temperature, we call cold junction, and the one which is higher temperature, we call hot junction. Is it clear?
Yes, sir. Thank you.
So it's not like you say place ice at a cold junction. Actually, it's not like place ice at a melting ice as a cold junction. It is like placing an when we place an ice in comparison, the place where we connect ice to junction that appear to be cold. That's why we call that as a cold junction. But before connection, there is no hot and cold junction. Only junctions are there. And junction means the point where the two wires are connected to each other. Experiment shows that the temperature of a surface depends on type of surface used. Describe a nature of surface that will cause a temperature to rise most, which will cause a greater change in temperature. So dull black surface will cause a greater change in temperature. A thermocouple is used. Another question. Another question, a thermocouple is used to measure temperature of inner wall of a pottery kiln. In a space, draw a label diagram of a thermocouple that could be used for this purpose. So, example, if this is the inner wall of the pottery, like it's a furnace of a pottery kiln. So, example, this is we want to record a temperature. This is a pottery kiln, and you have a millivoltmeter. The two wires coming out and the two wires connecting the junction made up of different material. I can mention junction 1. If you are confused with hot and cold, you can also mention junction 1, junction 2 and label them. That will be the correct answer as well. The next part, describe how you would read the temperature of the wall from a thermocouple and how the thermocouple works. So how the thermocouple works, that's a 2-mark question. And how we read the scale, or how we read the temperature of the wall. Yes, how we'll read the temperature of this wall. Attach the junction to inner, and yeah, the full answer is like attach one junction to inner wall and the second one is to the inner wall of a pottery kiln and the second one with a pure melting ice, and check the voltmeter reading to calculate the temperature. And then how a thermocouple works, the change in temperature produce voltage, which can be used to record the or measure the temperature. State 2 condition in which thermocouple is very suitable for temperature measurements. You don't have to find the scale. Scale will be given. You don't have to find a scale for the, because you are not doing experiment. So if you're not doing experiment, then scale will be given to you. State 2 condition in which the thermocouple is very suitable for temperature measurements. Like what is for really high temperature? That's one thing. Extremely hot objects, correct? And the second thing, because you want to mention two conditions. First condition is it can record a very high temperature. Second condition, it can record a range of, yeah, responsive, quick acting, sensitive, small change in temperature. So you can mention many answers according to the question here. Now in this question, you can see a small difference in this thermocouple compared to other thermocouples. Like what you will find a small difference here in this thermocouple, instead of, so this is a copper wire and this part is a cold junction. So basically what is the reason why? Because normally when we use, like if this red part is representing a copper wire, then there's also another copper wire, and the wire which is connecting the two, that's another material. But if you want to use only two wires, like not the other copper wire, so you can just take out different wires from the meter. So the voltmeter part is called a cold junction. This region is called a cold junction, and the other one is a hot junction. Describe how a thermocouple could be used to measure the temperature of a beaker of hot water. So how we can use, the same answer is there. So the difference in temperature in between hot and cold junction produce voltage, which can be used to determine the temperature, and one of the junction must be calibrated. Like you should know the temperature of one junction, so you can determine the other. State 2 situations where the thermocouple would be a good choice of thermometer to measure temperature. Again, like advantages or choice, range of temperature, greater range of temperature, can record a very high temperature, sensitive, responsive, even can record a temperature at a narrow place. Like example, if I want to record the temperature of the wall, so normal liquid in a glass thermometer is not a suitable. Why liquid in a glass thermometer is not suitable to record the temperature of the wall? Because when I place liquid in a glass thermometer, the bulb of a liquid in a glass thermometer is not completely in contact with the wall. So if this bulb is not completely in contact, so it will not be suitable to record the temperature, or it will not show the temperature of the wall correctly. Why? Because you can see only this part is in contact, small part is in contact, and most of the part is not in contact with the wall. So for this purpose, the best one, we can use thermocouple, because the wires are there, like a small hole we can make in the wall and then put this wire inside, which will record the temperature of this wall accurately. Is it clear? So thermocouple for narrow place, it can be easily record the temperature accurately, but liquid in a glass thermometer, not having a complete contact, so it will not be suitable. Any doubt in this part? For solid, it can be used, but the thing is, if for example, if we can make a space for this whole bulb, like whole thermometer bulb can be inside, then we can use it. But practically, like, it's difficult thing to do and place a thermometer completely inside a solid. So normally we use liquid in a glass thermometer for recording a liquid temperature or temperature of the gas or surrounding. But solid can be used, but it should be completely immersed or completely inside the solid. Like you have to make a drill in the solid, and then, yeah, it is inconvenient, but it is possible. So these are the questions related to thermocouple. Any doubt related to the class today? And submit your weekly homework tomorrow before the class, physics weekly homework. So block one, we finished block one, we finished already, and this is a block two, last topic. So two blocks are done. The block three will start tomorrow, and hopefully, inshallah, we'll finish within December. So we'll complete like 75% of the syllabus will complete at the end of December. Five blocks are there, and we finished two of them. So now it's short, like block one and block four, greater weightage as compared to block 2, 3, or 5. 5 is like maximum 2 classes, block 5 will finish. So it's not a lengthy topic. So I'll end the session and share recording.